Okay, now we are at part D, which says the activation energy for a reaction is blah, blah, blah. The rate constant, so activation energy, this is the EA, rate constant K at a certain temperature. So we can say this is going to be K1 and this is going to be T1. And then they said, what is the value of the rate constant at this temperature, which is T2? So the moment you get two temperatures, we said you're going to use this version of Arrhenius, which says ln of K2 over K1 is equal to EA over R, then multiplying 1 over T1 minus 1 over T2. If this says K2 over K1, it will be 1 over T1 minus 1 over T2. So now what we want is going to be K2. So we'll just first calculate. So here, what is our activation energy? Activation energy is 31.85 kilojoules per mole, okay? Per mole. Divided by, what is R? R is the rate constant, and they said the rate, R is going to be, sorry, not the rate constant. It's going to be the universal gas constant. And we are going to have to go to the front of the paper to get it. Let's go together. So we go to the front and we get the R. Where is R? Are they going to give us? Seems like they won't. Wow. Really? You won't get R? So you're going to have to remember R. Okay? You're going to have to remember his. All right. So, and his value is going to be 8.31. You can have it as 8.31 moles. Okay, 315. You could put it as 315. Then you would have joules times moles to the minus 1 times Kelvin to the minus 1. Which you can say joules per mole per Kelvin. And this is going to multiply 1 over, what is our T1? 50 degrees, but we are going to change it to kelvins. Remember how we do it? We are going to say that absolute 0 kelvins is equal to negative 273 degrees Celsius. So to come from degrees to kelvins, you add 273, because you want to come from negative 273 to go to 0. And from kelvins to degrees, you subtract 273 degrees. So in here, we want to come from degrees to go to kelvins, okay? So we have 50 degrees. So what do? We add 273, okay? We add 273. And we would basically get it as 323 kelvins minus 1 over, minus 1 over T2. What is the new temperature at 63 degrees? So we'll just say 63 plus 273. It becomes 336, 1 over 336. That is what you have here. And remember that this is ln K2 over K1. So you get an answer. And then when you get your answer, this answer, remember that you're going to take first thing, ln to the other side. So you say K2 over K1 is equal to, ln goes to the other side, becomes E. So it's going to be E to the answer. Then we'd say K2 is equal to E to the answer times K1. Okay, whatever answer you're going to get here, you say E to that answer, then you say times K1, and that is it. Okay, and that is how you get your K2. And you are done. Okay, you are done. So that's going to be it. And then now you can, let's see if they ask, what is D part 2 saying? Part 2, D part 2 says, besides increasing this, okay, besides increasing the reaction temperature, how else can you increase the rate constant? By adding a catalyst. Adding a catalyst is another way. Okay, adding a catalyst. So that's it. That's it. Now we can see about part B4 and go and learn more. And that's it. Okay, for now we'll stop here and pause the video. See you in the next video.